Alright, in this video we're going to do another empirical formula compound problem. So, let's start off. So we've got chromium, so let's pick a black color here. So here we've got 68.4%. Now remember, we're going to assume a 100 gram sample in these problems, and the reason why is 68.4% of 100 grams is 68.4 grams. So by assuming a 100 gram sample, you can essentially take this percentage and turn it into a gram, and the same thing for this. So when we assume a 100 gram sample, these percentages now turn into grams. So I have 68.4 grams of chromium, and I have 31.6%, oops, not percent, grams of oxygen. So now let's go ahead and see how many moles each one of these are. Remember, your moles are basically your bridge for getting from one unit to another unit in these type of problems. So to cancel out grams of chromium, let's put grams of chromium on the bottom, and I want to know how many moles of chromium that is. So I know in 1 mole of chromium there are 51.99, let's just call that 52. That's really close. 52 grams of chromium for 1 mole of chromium. So this is just the mass number of chromium that you get from the periodic table. So let's go ahead and find out how many moles of oxygen we have. So I've got grams of oxygen here. To cancel out grams of oxygen, you put grams on the bottom, and I will put 1 mole of oxygen on the top. There's 16 grams of oxygen in 1 mole. So now let's go ahead and calculate. Let's do the chromium. So I'm going to say 68.4 divided by 52, and that gives me 1.31, say 54. Okay, and this is moles of chromium. Now let's go ahead and do the oxygen. So we'll say 31.6 divided by 16, which gives me 1.975 moles of oxygen. Alright, so if you guys remember that empirical formula is basically the lowest whole number ratio, so we need a ratio. We've got the moles here, now we need a ratio. So you take the smallest number of the moles and you divide each one of the moles by the smallest number. So in this case, 1.3154 is the smallest number. So I'm going to divide this number by 1.3154, and when I do so, I'm going to get 1. So in this case, I'm going to divide this number by the same thing, 1.3154, and then let's get an answer. 1.975 divided by 1.3154, and then I'm going to get 1.501. So now let's switch colors here. Let's go to blue. So now typically this is the number that we would put next to the symbol, because this is your ratio, 1 to 1.5. But if you remember, empirical formulas is your lowest whole number. So we're looking for whole numbers. So 1.5 is right in the middle of 1 and 2. So I can't really round this to 2, and I can't really round this to 1. So in order to make this a whole number, I need to multiply this by 2. So if I take 1.5 by 2, I'm going to get 3. But whatever you do to one ratio, you have to do to the other. So I need to take 1 and multiply that by 2 also to get 2. So now these numbers are whole numbers, and these are the numbers that I want to put into my formula. So I've got chromium, so I'm going to say Cr, and the number for chromium is 2, and I have 3 oxygens, so then I've got O3. So this is the empirical formula for this particular problem, Cr2O3. Now you may have a problem where they ask you to name this. So if you remember, chromium, Cr, is a transition metal, so it needs a Roman numeral with it in its name, and we know that O is oxygen. So one way that I say to do this is the charge on chromium we don't know, but we can find that from oxygen. We do know the charge on oxygen, and let me switch colors here. We do know the charge on oxygen is a -2. So one oxygen has a charge of -2, but there are 3 of them. So 2 times, or -2 times 3 gives me -6. So on this side of the molecule, or the compound, I have a -6 charge. So in order to cancel that out, I need a +6 charge on the left-hand side. So if we kind of divide this into halves, this side of the molecule is -6, and this side of the molecule, or compound rather, must be +6. But I have 2 chromiums. So if I have 2 chromiums, let's go ahead and draw them out. So each chromium must be a +3 in order to get my +6. So +3 plus 3 gives me a +6. So this is the number that goes in the parentheses. So this is the number, or the charge, on one atom of chromium. And then we just put oxide on the end. And remember, IDE goes on the negative one, and the naming convention is positive comes first, and then negative comes second. So all in all, the empirical formula would just be Cr2O3. That's the empirical formula. But if you were to ask to name it, it would be chromium 3 oxide.